All right, thank you so much for joining us this evening. My name is Elise Rosemarin. I'm a Senior Vice President here at AKAM. Tonight we'll be celebrating Earth Day and having a discussion revolving the opportunities to reduce carbon emissions and Local Law 97 compliance and how that will, how we'll be proceeding in the next few months. All right, joining me this evening, I have my esteemed colleagues as well as an industry leader, Michael Scorrano, who is joining us from Empower Group. Matt Resnick, who's the Director of Project Management here at AKAM, and then Matt Cebula, who is our Director of Energy Services. Thank you so much for joining us. All right, so a little bit about our panelists. Michael Scorrano has had over 25 years of experience and founded Empower Group with the vision of developing an engineering firm that does everything regarding energy management and makes it better. With that simple vision, Empower Group evolved into an engineering firm that designs, develops, and delivers comprehensive, integrated, and practical energy solutions from concept to completion. Empower Group applies practical solutions to complex energy needs to maximize savings and reduce environmental impacts for its customers. Thank you for joining us tonight, Michael. Matt Resnick is the Director of Project Management here at AKAM. Matt and his team are experienced project managers and bring their leadership and distinct expertise to each job, ensuring that all project needs are assessed and that proper procedures are followed from conception to completion. Thank you for joining us, Matt. And lastly, but definitely not least, we have Matt Cebula, who oversees our energy department here at AKAM. He provides substantial benefits to the entire AKAM portfolio, and he has dealt with everything regarding energy matters, including procurement, account audits, local law compliance, as well as the energy efficiency measures. Welcome, gentlemen. Let's get started, shall we? All right, Matt, I think that you're going to discuss the overview for tonight. I think you need it.
Yes, thank you. So tonight, the main question we want to help you answer is, what can I do for my building as it relates to Local Law 97 and greenhouse gas emissions? So, we'll start with a quick data overview. Mike Scorrano will then go through various types of building plants that you might have, and then what you can look for, and then we'll end with a case study, of course, question and answer to end. So the first thing we want everyone to know is that, kind of as expected, the 2020 energy data is skewed based on COVID. We were forced to shut down amenity spaces. Many residents went to other homes if they had the means. Some renters chose not to renew leases. And so we saw big dips in actually energy consumption 2020 over 2019. So we're recommending that the first step in this process is to verify your data to make sure you have the proper score. And that's based on your building characteristics. And instead of using that based on the 2020 data, we're recommending that you use your 2019 data to create that true baseline so that you know if you even have to do any projects, if so, how many, and how to help get there. So at this time, I'd like to introduce, Mike Scorrano to quickly describe his company, and then to go into more detail on what to look for in your particular buildings.
Again, thank you very much, everyone, for inviting us. Thank you, Elise, for the intro, and Matt, good summary of some of the stuff for the benchmarking for this past year. So again, thank you with that. Again, I'm Michael Scorrano. I'm the Managing Director of Empower Group. We're an engineering company that was founded in 2003 by myself, and certainly we've been working with a number of AKAM buildings to try to identify and help implement many cost-effective measures. We have, a big team of 40 people in New York City area. Obviously, a lot of us are certainly working remote right now with the COVID and looking to get back into our office come maybe after the summertime. But we're here to kind of assist a lot of the AKAM portfolio on various projects, and we certainly have a good unique way of looking at projects together. Actually, it's not a photo case. That's actually people that work for Empower Group. So Sean and Michael. So if you happen to actually use our services, you may actually get to see them on site. But again, you can move on with the slide. I don't know if I have control or not of this. Thank you. We do a lot of services, not to get them all, but we work with Matt and Matt's team on energy efficiency projects a lot, but we can certainly handle anything from conceptual review of the buildings, and we'll talk about Local 97 and how we kind of come into that play and how we can help assist once we identify energy efficiency measures, work with Matt and Matt's team in order to basically implement them going forward. So that could be anything from simple energy efficiency measures that are in buildings to things that could be, renewable energy in terms of code generation and on-site power, to doing other things that are outside of the building envelope. And we work with not only multifamily buildings, although that makes up probably 75% of our portfolio of buildings that we work with, just because of the sheer number in New York City. But we also work with hospitals, healthcare, and industrials all around New York City. So again, we just pride ourselves that we're a good full service shop for that. Move on. And as far as what we've done, we audit a ton of space in New York City. There's a whole thing called Local 87, which we've done a number of AKAM projects as well. We've done 900 plus of those, so I think we're the largest provider in the marketplace. And the other thing that we like to do is try to find as much incentives back as we can and save as much money. So I think if you look at our portfolio of stuff, I mean, we came up with a number of $80 million of potential energy efficiency savings. I don't know, that could be more. That's probably what my staff pulled together, some of the stuff, but I've been doing this even before I founded Empire Group. So certainly a lot of stuff that we obviously come across in terms of energy savings. And the big thing we pride ourselves on is we have recovered a slew of money back for multifamily buildings and other people to basically help implement these measures. So we're very versed at pulling all the incentives together to help make that projects more cost effective for buildings. Move on. So we're here talking about Local 97, and certainly the backdrop of Earth Day is something that obviously is important. Actually, 2 years ago at this time, on Earth Day 2019, is when the City Council actually looked to put Local 97 in process. Local 97, along with some other laws, which we don't, 95 and various other ones, were passed as part of a larger offering of different measures. But the big one that has teeth and certainly can help hurt buildings going forward is Local 97. So the big takeaway on Local 97 is to know that starting in 2024, buildings over 25,000 square feet, which encompasses, I think the number may be almost 20,000 buildings, are mandated to meet certain carbon emissions or pay penalties. The city actually has an overarching goal of 80% carbon reduction by the year 2050, using 2005 as their baseline. And again, so what they did is they enacted this law in order to kind of, help or force buildings to try to meet carbon emission limits and reduce the overall carbon emission to make themselves reach the goal of that 80% reduction. And in 2024, they start, and we'll get into maybe one of the slides shows like how many buildings have to comply. But typically in 2024, when we did the original data, about 25% of the buildings that are out there in the whole New York City will be impacted by this law in terms of emission penalty. And then in 2030, when the laws become more stringent, about 75% of all buildings would be impacted when they first put the law in action. And really what 2030 actually represents is, well, I talked about the 80% target reduction. They're looking at the 2030 as the halfway mark of that. So, they still have to get to 80% reduction. And in 2030, the city then, if everybody met the goal of that without, and wasn't paying penalties, they would actually be at a 40% reduction in overall carbon emissions. Move on. So Local 97 looks at emissions of building, like carbon emissions, and it really depends on what type of building you're at. So when they put the law into effect, they tried to break the law down into manufacturing, to industrials, healthcare, hospitality, and obviously multifamily, which is most important for the audience here. And they applied certain limits to it. And again, if you look at the left-hand side of the screen where it says 20 to 24, multifamily buildings have an emission limit of 675. That's tons of metric tons of carbon per 100,000 square feet. And you can see that in 2030 to 2034 reporting period, we're going to see that reduced by another 25% or roughly or so. And again, that 2030 to 2034 goal represents the overall target that the city's trying to hit. And that represents 50% way towards that target of 80% reduction by 2050. And of course, as you get out to 2050, the emission level should obviously drop down on average. And the reason why you see 2035 to 2049 is sort of blank is the city's still trying to assess, what those emission limits will be and how the penalties will impact. And the reason why it's like that is because in addition to the city trying to have an 80% carbon reduction target, the state on its own is trying to basically have almost 100% renewable energy portfolio in the market by 2040. So what they're trying to do is, from the city's perspective, make people reduce the amount of carbon emissions they're using. And from the state's perspective, put a bunch of renewable energy in the market, renewable being wind power, solar power, increasing maybe hydro with Hydro-Quebec, and other things that are non-fossil fuel to make the amount of electricity that you're purchasing carbon-free, and obviously help almost by default reduce the scores that are there. So obviously we have to see how the state is doing on their goal, but again, that's their target. And there has been a lot of movement, if you've looked at the papers, in terms of offshore wind off Long Island, a lot of upstate solar, talking about pipelines or power lines, just say, coming down from Canada to increase the amount of hydro that we can bring into the state. So all that stuff kind of ties together with this overall like 97, but from a building perspective, you're rated on how much carbon you emit based upon the factors that the city will put together as time draws on. Move on. And again, like we said, each sort of carbon dioxide, each amount of penalty associated with the CO2 levels is tied to the different types of fuel. So if you looked at sort of the pecking order of penalties, district steam would have less dollars per kBTU of overage than number 4 oil, which would have more than 2. Steam is the lowest. Number 2 oil natural gas would be second. Oil number 2 would be third. Number 4 oil would be fourth, and of course electricity would be fifth. But again, that assumes right now, based on electricity, that we have our current mix of generation in terms of fossil fuels, and we obviously fully expect that number to drop over time. And we'll get into so why is New York State and the city pushing buildings to electrify going forward? So you can move on. So the big thing of why, if you've listened to some of the news too, and again, based on those carbon scores and penalties, there is a big push in the state to electrify buildings and try to move buildings off of fossil fuel and move into something that's more electric. And that's really a two-part answer. One of the answers is the one I described before, that as the state tries to put more renewable energy into the marketplace, we do fully expect the amount of CO2 per output to basically go down. Why? Because if we're making our electricity with solar, wind, hydro, those are non-carbon forms of energy, because those are coming from renewables. So therefore, the amount of emissions would be on carbon dioxide would be basically close to zero. And the second part of the equation on that, if you look at how new construction is happening, the amount of efficiency that you can get from either trying to do things that are heat pump related, which is using electricity, and tying it into like newer construction mechanisms, you can actually reduce the amount of energy intensity of that footprint that you do. And you can kind of see from this example that if you started from something that had electric air conditioning and gas fired making hot water, that's going to have a certain annual energy use and a certain score. And as if you basically increase the energy or decrease the energy consumption by improving the outside of the building, using heat pumps to make electricity and heating, and have gas-fired domestic hot water heating, you can certainly reduce your annual energy expense as well. And if you went to something that was brand new in terms of very passive house, something that's very tight, very energy efficient, and uses all electric to both make heating, cooling, and electric and domestic hot water, you can see how that reduces your annual consumption further, improves your score, and obviously reduces your carbon impact going forward. So, obviously looking at all this stuff, for Local Law 97, it's like, okay, now that, if I can look at my building and I know that the AKAM team certainly sends out the benchmarking reports and they have letter grades associated with them, and we can certainly easily look at ways or where your current carbon emission penalty is. But you obviously have to put a roadmap together in order to be able to kind of figure out what opportunities you have to make the building better. So we tend to attack a building in various sort of components. And one of them would be starting with the envelope of the building. If the building obviously is not as leaky, not wasting energy, then obviously I don't need to make as much energy for the building. And that could obviously reduce my carbon score. Certainly ways to do that is certainly windows, obviously a very expensive thing, especially in New York City. but certainly where windows need to be done or the building already has in their capital plan, certainly that would make a very big impact on carbon emissions. Walls or increasing of insulation, we see is certainly something that also helps out. And anything that we can do with roof improvements, which is obviously probably more, we see more happening more and more, especially to existing buildings where roofs need to be replaced. And if you look at the new energy code standards that are in New York City, the amount of energy codes, the standards are very high, meaning that we have to put actually a lot of insulation back into the buildings. And that obviously has a big impact on the heat loss or basically the heat gain in the summertime. And then what the city has also done in the state and in general across all the energy codes, that the standard codes that are out there, is anything that's new, they're looking to obviously have buildings that are very tight, not leaking. And because the more air I either lose or air that comes into the building, the more I have to heat and cool that location, and that just leads to loss. So we see a lot of opportunity, especially in envelope upgrades over time, especially for us to try to hit the 2030 through 2050 standards as we get through a lot of the energy efficiency stuff and in the normal stuff we'll talk about in a minute, which is the central plant and some of the locations in the building.
Can I ask a real quick question just to go
Sure.
back? So the energy grades themselves, can you just extrapolate a little bit more as far as the A, B, C, D, how those come to be? Because I don't know that everyone knows exactly how that came out.
Yeah, I'll certainly talk about that. So there are two parts that came out there's carbon emissions, which is the local 97. There's also a component on letter grading. That's what your thing's going for. And they are two distinct sort of things, right? So the letter grading is really a function of how you use energy, right? And as long as you can use energy efficiently, no matter what form of energy it is, then you could actually increase your letter grade and have a better score. So we definitely see buildings that are burning number 2 oil, buildings that are burning 6 oil, that are at least doing it efficiently. Therefore, their score looks pretty good as an A, B, C, or D rating. But again, the other part on local 97 looks at carbon emissions. So carbon emissions can take on twofold. One is, how much fuel do you use? So, comparing one building that's using the same type of fuel, if it uses less, it's going to produce less emissions, therefore less carbon. But when we do switch to lower forms of fuel, then we actually see a reduction in carbon. So again, that ties into the whole concept here of trying to move buildings off to either less carbon intensive fuels, like getting off of 4 and going to 2 or natural gas, or going all the way to electricity for some of the applications that we have. And we have seen buildings who, again, utilize, who do have a very high efficiency in terms of a score, but again, because of the form of fuel they're using, they could have a very high use of carbon. So they may have a good score and a poor use of carbon. So again, it really goes hand in hand, but generally, they are distinct, separate, and we try to kind of attack both, meaning we like to reduce energy consumption, but we also like to then switch to lower forms of fuel, carbon forms of fuel, in order to both increase the letter grade and obviously decrease the carbon emissions going forward.
Thank you. And then, is there a difference between like age or for buildings, for example, are they looked at the same just as a grading scale, or is there, flexibility?
No, good question. Unfortunately, the way the letter grade works and even the carbon emission penalties work, there's really no distinction between age of buildings. So there's nothing like in the setup when you do that stuff on the portfolio tool that says, oh, this building's built in 1990, therefore it should be better score or worse score. It really looks at, most of the time, it's square footage of the building type, and there's some other questions that come in there, but generally the biggest thing that drive it is the energy consumption, the square footage, and the building type. And that'll basically drive the calculations. So we have seen a lot of buildings that were built, I'll call it right up to the turn of the century, that you have very low amenities. They have just, they may be a steam building with maybe a limited amount of window air conditioning, and they may have a very high energy score, and they may even have a low carbon usage because, again, they're just not using a lot of energy per square foot because they're not really heating and cooling or a lot of amenities in that building. And then we have newer buildings that, were built with big windows, it has a lot of heat gain, has a lot of amenity spaces, and that on a per square foot basis, it may be using a lot of energy for one, and then obviously their carbon score is high because, again, per square foot, they're just emitting more energy, and they may be in a crummy form of fuel that'll obviously hurt them. So again, it really depends on what's going on that.
And with that, you know, your score is based on your actual building characteristics. So that's why we always say, and I'm sorry to be repetitive, like make sure your data is accurate. We've seen square footage underrepresented. We've seen retail space not even counted. And in about 40% of the buildings that we've actually looked at the data, we were able to modify the score just getting the data right alone. And that would produce the true baseline for you. You know, as Michael and a team like his or even a competitor performs an engineering evaluation, you would know what to do based on that true data.
Can you share a little bit about why retail or the square footage would matter in that case as a benefit?
So in an oversimplified way, the more apartments you have in a building, the more square footage, actually the more carbon you're allowed to emit. So when you do those energy efficient calculations, which again, oversimplified is your consumption divided by your building characteristics, changes to those can have a massive impact.
Good to know. And then as far as age is concerned, the building, it's not necessarily the age of the building that has more of an impact, it's amenity and I guess window impact.
Yeah, again, like Matt was saying, it's really your overall energy consumption of the building. So we do find a lot of old buildings, like turn of the century, even pre-war stuff, because again, they don't have a lot of amenities, therefore they don't use a lot of energy per square foot, relatively speaking, or they're a little bit more dense in terms of how the apartments are set up. They just seem to have a better score than something that was maybe even new, that has, even though it was designed to newer standards, it may have a lot of heat gain, it may have a lot more amenities, it may be centrally heated and cooled. And again, it's just going to drive the score up more. So, again, we see a large gambit of buildings, and certainly we see buildings that are all over the place. And it really just depends, again, a lot of times on just how the actual energy is consumed in the building and how all that stuff kind of comes into play. But the big thing for us is then to kind of figure out, like first thing, like Matt said, is make sure the data is good. Make sure that you guys go through the data, and we have seen as well, where just some simple setup things on the portfolio manager when you do your local 84 benchmarking can make a big difference on both your energy score and also your carbon emission component. And then on the same time, put together a comprehensive reduction plan of various measures, which again, these type of things that we're going through will kind of give you some ideas of things that you can kind of go through and look at.
And for everyone's, just so we all know why this, not only is it important from, an energy global standpoint, it's because of the penalties also that will impact the building eventually. So that's why we want to be ahead of this rather than, we want to be we want to be proactive, not reactive in this method.
Right, exactly. Also, real quick, from a process perspective, there's some questions that are coming up. I don't know when you want me to answer those, or
sure, yeah. So what we'll do, we can answer now, or as we actually are getting a lot of questions. We can answer a few right now. Sure. Okay. So one person does want to ask a question. We can get back to the presentation, but are there rebates, because this is potentially an expensive undertaking to change these things drastically, potentially in a building. Are there any financial incentives for comprehensive window replacement projects, as an example, that yield carbon emissions for a residential building?
Yep. So the good thing is there is a lot of incentives that are out there, and it depends on the specific measure that we're talking about. Again, in relation to central window plant, yes, it depending on the building type. If we're able to do a comprehensive window upgrade and there was a gas reduction component to that, we can get incentives back now. So the answer is it's a yes/no question answer, I should say. Depends on really the building type, what the actual fuel that the building's using, and then what measures you're doing. But definitely windows could potentially be a rebatable item or portion of it or some part of it. If it's a gas building, there are obviously a lot of rebates for electric upgrades, and that could be from lighting to variable, we'll get into some of the stuff, variable speed drives, and I can point out when we hit some of those things if it's a rebatable item. Boilers are a big upgrade, controls, so there's definitely a lot of money that's out there. And in parallel as well, the city is also looking to put in various financing tools through some of the PACE programs that are out there, as well as there's other third-party financing that could be kind of low cost to help you make the improvements.
And those incentives aren't just for the installation of the project themselves. There's actually funding available via NYSERDA's FlexTech program to get rebates for just the engineering of it alone before you even start the work. So depending on your project, you should absolutely look into if that's available to you.
Yeah, so when we do a local 97 report or even a local 87 report, I mean, if it's definitely a more complex building, we definitely utilize a nice sort of FlexTech program. And in order to access that program, you have to work through a FlexTech provider, which we're one of them. And what NYSERDA will actually do is they'll cost share the cost of the study with you. So again, it's a good way for someone to get a comprehensive review of the building while having the state pay for a portion of it. And certainly we utilize that program a lot. At one point we had over 100 applications in, and we had, we were like, oh, you have to stop for a little while. And, we obviously just managed them and got them through, but definitely it's a good program. And we certainly been taking advantage of it, ever since we've been doing studies and rebates going forward.
Oh, that's fantastic. So it's good to know at least, yes, this is costly, but there are solutions out there to help buildings, from a financial standpoint. That's good. And then one last question, then we'll continue on. What if our building is dependent on a third party for steam? If this case as a central plant from an adjacent cooperative and there is no meter, excuse me, I've got some energy coming in my building, don't worry about it. No, there's no metering to determine our actual energy flows. I don't know if I asked that correctly, but essentially it sounds like the person is dependent on a third party for steam. So how do you handle that?
So what you have to do is obviously you're trying to do your best to try to break down the usage between the two different locations, because obviously the person that's selling the steam to you, the other cooperative, obviously is totalizing all the energy they're using to make that steam. And obviously from your building's perspective, you'd have to do your best to have an engineer, for your submission to basically be able to estimate what that usage is. I mean, clearly having meter data, even to have as a check, I mean, I'm assuming they're billing them, so there's got to be some usage there. But if there was nothing, it would have to be an estimated use. And obviously, it may become a little bit more important to try to figure out a way to put some third-party metering in there when we get closer to the 2024 date, because obviously, the best guess that I have isn't going to be as good as having actual meter data. So again, it's just something that they have to consider, but definitely it would have to be somewhat, get the raw data from the co-op that's supplying it, trying to do your best allocation of what usage that you would have as your building, and that could go into your score. But I would obviously recommend certainly over time to put some sort of, metering system in yourself to be able to try to capture what steam's being sold to the building or served to it, so you can obviously accurately report your usage, and that impacts your score and potential carbon penalties going forward.
Thank you. All right, so now we'll continue, and then at the end, we'll do a formal Q&A. So everyone, please definitely put in all the questions and we will get them answered. All right.
Sure. Other things that are out there, certainly carbon reduction opportunities we look at is looking at the central plant. How is the building heated, and how do you make domestic hot water? Obviously are huge potential things. And certainly from an energy standpoint, the heating and the cooling and the domestic hot water of the building consumes, the majority of, especially in a multifamily building, consumes the majority of what the energy is going to be used for. So, certainly steam boilers and steam distribution, which is very, very common for buildings that are certainly anything older, and even some of the newer buildings, you'd be surprised, still utilized steam distribution when they were built, even a couple of years ago. But there's definitely ways to upgrade it. So we look at things like burners, taking the boilers, the blue thing that's listed in the picture there, which is the burner, changing those, upgrading the controls by making them more modern. There's a lot of measures that we look at in the distribution system in terms of steam traps, or if it's a two-pipe system, or if it's a single pipe system, we look at venting opportunities where we can make the steam get to locations better. So there's definitely a lot of opportunities there. Some of the more expensive things, it's like listed like hot water conversion. So you can take the steam and convert it to a hydronic type building, which would be a little bit more efficient, or, get into heat pump conversion and getting rid of maybe the steam boilers or the steam system where there could be losses, in putting something in there that would be more efficient electrically, that would help drive down the carbon component. And then other things too, in terms of boilers and steam boilers and hot water distribution. So if you have a boiler that's making steam, but then the steam goes into an exchanger that converts to the hot water that you're pushing around the building, there's definitely some things that we've done on that in terms of putting in more efficient boilers, and also looking at more potential heat pump conversions, if we can get the efficiencies to kind of work out in some applications.
So are you advocating for heat pump conversion, and would it save energy or?
So heat pump conversions, some of the heat pumps on the VRF type systems where they're kind of individual seem to do okay and evaluate okay on that. Where I've looked at a bunch of central plant heat pumps, they don't seem to have the efficiency that I really think is going to drive it to want to change. So right now in my mind, at least on the heating side, I think we're a little bit away from being a little bit more where that stuff's going to kind of come into play. I think if it was a new construction building, we would definitely be looking at heat pumps, or we would design it that way. But from a conversion perspective, it's hard to kind of try to match some of if the building is running efficiently, it's hard to kind of try to match some of those efficiencies and some of the stuff that we look at. But again, it's definitely something that we are looking to continue to pursue it as the technologies continues to get better and better and better, and the efficiencies get better as well. And just building more upon some of the stuff that we do in the distribution system. Again, control upgrades is always a big one. Heat pump conversions, especially if we're doing cooling of the building, as well as looking at, and depending on the structure of the building, we can put in the heat pumps as well for a VRF or central system. Condo district steam, we definitely have looked at converting a lot of those, especially if they're, hot water distribution system. We've obviously looked at ways to kind of make those more efficient. And then certainly electric heating, where we have electric resistive heating, that's easily a location where going to a heat pump would save an immense amount of energy, cost, carbon, and everything, and certainly make it much more better, beneficial for the building. And the picture there is just something that we did for one of the AKAM buildings. We put in a brand new boiler control system. Then we were able to monitor it 24/7. It gives alarms, it gives notification, and it also allows us to adjust parameters remotely. If we see the boilers are getting out of whack, we're able to kind of adjust things to make things a little bit better. And the good thing about controls is there's rebates associated with them as well.
And Mike, do you mind just elaborating on RTEM and how it all factors into this?
Yeah, so there is an opportunity for rebates called RTEM, or real-time energy monitoring. So what NYSERDA does is they have a program that allows us to implement a control system for real-time active monitoring of buildings. And when they do that, they provide a financial contribution back. Right now, they're incentivizing 20% of the install cost, and they're also subsidizing sort of the ongoing expenses associated with having this real-time energy monitoring software in your building. And the reason why you'd want a real-time energy sort of platform is because if we can make all the changes in the beginning and do all this great stuff, but if someone's not watching the store, we're not going to obviously get the savings that we're looking for. So what we do on this RTEM program is actually every 6 months, we'll send out a report and a snapshot of like, here's how you use energy over the past 6 months. Here's the things that you actually could improve upon. Here's some of the parameters we would adjust going forward. And it's always trying to actively do that. And in addition to RTEM, Con Edison has their own program that actually right now for buildings over 250 residential units can pay up to 70% of the cost of the install for a little bit simpler system. But again, it definitely is something that's good. So we're a big advocate or fan of control systems, and certainly like to implement them going forward where it makes sense for buildings.
Great.
Other opportunities for carbon reduction, certainly domestic hot water. It's interesting when you start looking at fuel in buildings and how much energy goes into each component of the building. Well, it turns out that just making hot water in a building probably could eat up almost a third, if not more, of the building's total usage of fuel. So it's just amazing when we start like taking the energy data and sort of breaking it down into heating, cooling, and air conditioning and heat and domestic hot water, that actually is a very big number. You would think that making hot water for a building would be a small piece, but if you look at it over the course of the year, we could see anywhere from 25 to 40%, and typically a third in my head is what I usually think about when I look at a multifamily building. So by attacking the domestic hot water usage and making things that are definitely more efficient, or switching the fuel from something that's more carbon intensive to something that's less carbon intensive for local 97 purposes, we can definitely look to reduce energy consumption and reduce carbon. Obviously, the first one on the bullet point, low flow fixtures, is sometimes a controversial thing, especially if it's a building that, it's a bunch of shareholders. We always throw it on our recommendations. Certainly, I've seen a lot of apartment complexes clearly where it's renters, where that could be done on a mass scale, but it's kind of hard to, advocate for someone to change their showering head and at least the shower head, I should say. Everybody likes how their shower feels in the morning. But again, it definitely, if anything new, the good thing about it, I should say, is anytime anybody renovates a bathroom, I don't think you can buy a shower head or a faucet that's not, low flow at this point in time. And most of the time we see that we're talking about older stuff that's out there. And some of the other things that are sort of in the boiler room, and there's a picture there as well, we like to put in smaller boilers to make domestic hot water. If you think about it, the heating boiler of the building a lot of times has dual functionality, meaning it'll make the heat in the winter and it'll also make the domestic hot water year round. Well, again, because that boiler size for the heating load, it's way oversized to handle the domestic hot water in the summertime. And we just see a lot of loss that happens. So what we do in a lot of buildings, we'll put separate systems in there to basically either A, run in the summertime, or B, run year round, because the smaller boilers also, because of the size and how they're configured, just are more efficient than the bigger boilers. And that actually helps reduce energy going forward. So that's definitely something to do. And then a current trend that we've seen it is using heat pumps for some of the domestic hot water as well. It does work pretty well. It just depends on the application where it's going to be, but certainly that's something that would basically help shift, maybe not as much on the energy score side, but definitely on the carbon component to basically try to move stuff from fossil fuel over to electric, which will be a lower form of carbon going forward.
My question, can you explain a little bit just what is a heat pump and what is a heat pump conversion? Because you're an engineer, but not everyone might know.
Yes.
I certainly don't.
Okay, no problem. So we talk about heat pumps. So heat pump would be a device that could basically, we can use it for two purposes. One would be heating and or cooling, but we'll just start with the heat side. So it would extract some of the energy out of the air and then use electricity to provide and make heat as a source. So you're sort of getting something, you're getting some free benefit from the outside environment, i.e. the air at this point in time. It's kind of a reverse refrigeration cycle is how it's kind of described. And by taking that heat out of and using some starting point and then putting some incremental electricity in through a refrigeration type cycle, you can make heating in the building that way by doing that. And because you're getting some sort of free source to start with, the incremental amount of energy you put in, you actually can be very efficient in that respect on doing that. And then conversely, the heat pump can also, most of the time, they can run as a air conditioner because that's the cycle that it's using. So what they do is they'll take the heat from the building and they'll reject it outside as well. So it's just a way to make energy through electricity as a form through like a refrigeration type cycle. Again, utilizing in the wintertime some of the I'll call it the free energy from either the air. We also use heat pumps in ground source or geothermal applications, or in the summertime, basically extracting heat out of the space that we're working in and dumping that heat outside through into the air, or also geothermal, we can dump it to the ground as well.
Got it. Thank you. All right, you can continue.
No problem. So other carbon reduction opportunities, we do see a lot in terms of the cooling systems. So, we go into a lot of different buildings, especially if they were designed originally to be centrally cooled. We do see a lot of opportunities there. It's interesting that, we sort of see a lot of central cooling in sort of late 50s, 60s, 70s buildings. That's kind of when you really started seeing the sort of the foray of a centrally cooled building. And if you look at that, either the district steam one or the last slide, which is natural gas / oil, a lot of the buildings were done with the technology that was available at the time for centrally cooling buildings. So they would use Con Ed steam And what it says low P means low pressure absorber. They would use this very inefficient sort of air conditioning equipment that actually would take steam and through the cycle would basically make cooling. And if you look at that term we throw up there as engineer geeks, coefficient of performance, that just says, well, how much energy in do I need to make, or how much energy out do I get for how much energy in? So you can see that the district steam with a low pressure absorber or a single effect absorber, if you want to call it that way, has a very crummy coefficient of performance. So we don't get a lot, we have to put definitely a lot more energy in to get energy out. Then we can certainly look at some of the district steam stuff in terms of the higher pressure stuff, which has a little bit better efficiency, clearly. And also same thing with natural gas as well. And then the same thing with the boilers. But those technology is sort of like very limited in terms of how much coefficient of performance we see. And then if we move to other things in terms of electric chillers, and this is why there's also, besides the carbon component of how they make electricity, the electric chillers themselves have a much more higher coefficient of performance. So they just seem to do much better just because, on an electric chiller, because you have a cooling tower, again, you're using water, which has, energy in it already to help dissipate the heat. Therefore, you don't need to basically supply all that energy into the air conditioning piece of equipment to drive the process you're trying to do. So again, it just has a much more higher efficiency overall or coefficient of performance. So, and then so you can see the different levels there. And that's when we talk about the different technologies, why there's a big push of going to electrification of chillers, because again, the electricity in the way the cycle works is just much more efficient overall than using fossil fuels directly in forms of energy to basically make cooling as we go forward.
These are all out there that, and not, things that we know of, but making the decision to make the switch, for example, to heat pumps before maybe green electricity is available in quantity, is that something that you should be doing effectively, or should you wait and see what else comes out?
So on definitely on the cooling side, we're big advocates of getting rid of centrally cooled chillers that are absorption. Again, I mean, certainly up in as little as a few years ago, we were looking at a lot of gas-fired equipment. We would see a lot of old district energy steam low pressure absorbers, or we'd see the fourth example there, natural gas oil, boiler plus low pressure absorber. And we were putting in a lot of direct gas-fired equipment. But really, because of the coefficient of performance of the electric chillers, we definitely feel that they are much better to do now, and you'll save money, and obviously you'll use a lot less energy, so that will definitely help your your energy scorecard. And then also we definitely see, because of the the electricity component being more efficient and the electricity moving in the direction of being more carbon friendly, that's also going to drive down the carbon over time. So, we're definitely big fans of moving buildings off of definitely fossil fuel type of cooling and putting them over on electric heat pumps, knowing that it's more efficient right now, and that eventually we'll have a lot more greener energy in the marketplace that will help drive down the carbon emission component.
Great, thank you.
Thanks. Good questions. Another thing we see on a lot of buildings too is, we still see a lot of through the wall air conditioners, and we have looked at doing some types of heat pump replacements of those. So again, with the through the wall air conditioner can be replaced with something that can do cooling in the summertime, but also provide some heating in the winter. The technology is not 100% great to take you down to like 0 degree days, but it definitely helps some of the shoulder season days where you can kind of stay on and not have to heat your building up with the central system. So we definitely see there's opportunities to do that with buildings that have through the wall air conditioners that basically could then service two functions. One, that I could put some heat pump in there to make some electricity, use some electricity to make some heating. And then obviously when it gets really cold, go back to my central system. But again, what we're trying to do is do that shift to get off of fossil fuel, go to something that's non-fossil electric. And obviously that'll get you guys set up for the local 97 to reduce your carbon penalties over time as those penalties become greater and greater and greater, and the grid becomes a little more greener to kind of offset the use of those technologies. You can move on. Other carbon thing we see a lot is ventilation, and it's amazing how much energy that we see wasted this all the time. And actually, ventilation is sort of the two thing answer. So a lot of buildings, especially looking at post-war buildings, use mechanical ventilation fans to basically pull exhaust air out of the kitchens and bathrooms. And when those things were first installed, obviously predominant wisdom was let's just pull as much air out of the building as we can. Well, every time I pull air out of the building, I obviously have to bring air into the building. And the more air I bring into a building, the more I have to heat that air or cool that air. So that obviously leads to a lot of waste in energy. The other side is we see is a lot of the buildings too, especially older buildings, a lot of the exhaust systems are decayed or have failed over time, or we don't see a lot of balance between the bottom floors and the top floors. There's so many buildings that we actually go into where the top floor resident's getting all the exhaust coming out of his room, his bathroom or kitchen. He's happy, but then you go down to the first floor resident and they can smell their neighbor cooking dinner every night and they don't like the food they're making. So again, it causes a lot of angst in that way. So what we find is what we can do is really do a couple of things. One is by looking at the building and trying to look at where is that building originally designed to and where can we kind of reduce it down based upon the new standards and passive house ventilation standards that are out there. We can actually look to reduce the amount of exhaust air that we're pulling out of the building. And then we can also look to try to balance the lines over time. So by working at the building and focusing on each line individually, we can, again, reduce the amount of air we're pulling out, which reduces the amount of air we're pulling in, which reduces the amount of energy that we have to heat and cool the air, so that's a big energy efficiency piece. And then by balancing out that line, we use a lot of times constant air regulators and other devices, sealing of things in the shafts themselves. We can obviously make all the shareholders equally have a nice even distribution of exhaust air in their space. And that seems to be a very big component of energy efficiency that we've seen, which is generally overlooked a lot. Not that every building exactly can run that way, but we've seen, numbers and numbers of buildings that are involved with them to kind of do that. And the good thing on this type of measure, depending on what type of fuel you're using, especially if you're using gas as your heating component, you can get back a bunch of rebates associated with that. So again, we look at it in twofold: an energy efficiency measure, which would obviously reduce your energy, reduce your carbon score usage, and also provide a better indoor air quality by not having to smell your neighbors cooking every night before you go to bed. And then now some of the simpler ones that are bread and butter, I call it, electricity reduction. Certainly, things that, I should say that energy efficiency in the building really starts with everybody. So it's not necessarily, the board's direction or to do everything for the common area to try to make the scores better overall. Because like Matt had said before, the energy usage of the building in its entirety drives the scores or the benchmarking data, as well as the energy score, as well as the carbon emissions limit. So by focusing on things that are potentially in unit or other locations, we can reduce the amount of energy overall. So certainly, we always encourage, residents to basically do things like put in, or buildings themselves, high efficiency laundry if they have in-unit units or in the common areas as well. Dishwashers, clearly, by upgrading them over time, they're certainly better than they were years before. And obviously refrigerators are a big sort of use of in-unit electric load. And by replacing the refrigerator over time, as you upgrade, you naturally reduce the amount of energy you use in this space, which then impacts the overall building and helps on the energy score.
So this might be a way that, someone who might be in a very heavily new building with a lot of amenities and, the things that might tax against them, this might be a way that kind of counteracts it.
Yes, exactly. Or buildings we have some buildings, and we get into it in a second, on sub-metering, where they're a master meter building, but so their perception is that energy is free. But by making these changes in the in-unit level, we can obviously look to reduce energy going forward. But yes, especially if a building is got a lot of amenity spaces, by making sure at least the equipment that's there is energy efficient, we can hopefully drive down the energy usage and drive down the carbon score. Controls and building management system is a big thing. We showed some pictures earlier of stuff that's in the central boiler room, but those type of equipment can be expanded to include things outside of the boiler room that would basically help the building itself. So we use controls a lot for, looking at fan scheduling. We look at controls to look at turning off lights in different spaces. Definitely controls can have a lot of different impact. And again, by focusing on other spaces outside of the central plant, we obviously can make an impact on the building's overall energy. Lighting, which is a simple one. It's amazing how many buildings we do go into that, we have a lot of legacy lighting that's still there. And the payback on lighting is generally, 2 years or less for some things. And, 2 to 4 is not uncommon on an overall building to do that. So we look at a lot of lighting as an opportunity in building as well, especially going from, either complex fluorescent to squirrely bulbs to LEDs, going from linear fluorescence to LEDs, or even on the exterior lights, we can do a lot with LEDs as well. And, there's another thing too, sub-metering is obviously another component where we can kind of help on reducing energy in the overall building. I mean, sub-metering is a little bit it has to obviously tie into people's behavior, especially if a building, where we do find it has saved energy, and NYSERDA has done plenty of studies on this, is where a building is just master metered and they, residents and shareholders really don't know how much they're paying for energy. It's almost like my kids, they just don't have any concept of, what it costs to actually, run the TV, run the house, run this, and leave things on. But immediately when you start giving the bill and they say, oh, it cost me that much, and if it came out of their pocket, it's amazing how people will control sometimes what they use, or at least if nothing else, think about it. Think twice before walking out of the room or leaving that on, or at least if they know they're going to get a benefit of an energy efficient refrigerator, as an example, they make that investment. And Local 88, believe it or not, actually requires sub-metering of certain spaces, and also requires that buildings are in compliance with upgraded lighting systems. For some buildings, it could be as early as 2025. And then motor upgrades is another sort of electric reduction measure we've seen. So definitely anytime buildings are doing elevator motor upgrades in their spaces, that's definitely a prime area for buildings to reduce energy consumption. Just a side note too, we have gotten a lot of money back for buildings that were going through an elevator modernization. They were replacing the elevators with new motors, and they called us up, and obviously we did paperwork and studies to help facilitate getting money back for the motors for that. Pumps in the building is a big thing, and then we talk about this device called a variable speed drive or variable frequency drive, and what that is a device we can actually put on a motor to essentially just slow it down a little bit depending on how it's designed, and we actually can come up with energy savings associated with that because of the slower it spins, the less power it uses, and it's actually like a cubic relationship. So it definitely helps a lot on the energy consumption.
And I would just stress what Mike said in particular. If your building is upgrading really any motor, pump, or already installing a VFD, please let us know. The paperwork is fairly simple, and there are good rebates, and it wouldn't change anything that you've already specified, purchased, or intend to install.
And Mike,
what are your thoughts? Oh, sorry, were you going to say something?
Oh, no, I had a quick question for Michael, just to circle back to all of these projects. Let's say that you did perform an LED upgrade or a motor upgrade, and you had no idea that there were incentives available to you. Can you retroactively apply for any rebates?
No, unfortunately, the rebates are generally set up to their go-forward basis. There's one rebate program for electric vehicle charging that'll let you do it post-haste, but most of these programs want to basically see, what's there now and require that we get involved, that you guys get involved before that happens. So if you've done it already, it's generally too late. So that's why Matt stressed before that if you're even thinking about stuff, you should definitely get involved to be able to kind of move forward to help facilitate some rebates forward, because they kind of view if you've already done it, you didn't need my money then, so why should I give you money for it? They call it like a free rider. That's the word they use for it. So but that's a good question, Matt. Thank you.
Mm-hmm.
What are your thoughts on electric vehicle stations and as far as changing the charging stations if it's an outdoor parking lot? And is there some sort of local law that would have a specific section that allows them to deduct from that and apply it to their overall score?
Good question. So, part of the carbon target and goal and initiative that obviously not only New York State wants to do, but obviously federally, is that they're obviously looking to get as many electric vehicles out into the marketplace as possible, right? Because they look at, obviously cars burn fossil fuels create carbon emissions are bad, right? So that's part of that thing. So what New York State has recently done, end of last year, and we're working on a number of these, is they actually rolled out a program to help. They call it the Make Ready program, to basically try to put a lot of the infrastructure in place to support electric vehicles. So the state has actually $250 million in incentives to basically install electric vehicle charging stations all over the state. And when I say all over, I mean not private residents like my home, but private apartment buildings where people can go in there, public parking, anything that people would want to need or have the use for an electric vehicle charger. And they're basically paying 50 to 100% of the installation cost of the infrastructure required for that. And in parallel, actually, NYSERDA has a program to pay for the actual charging component. So again, this program just got rolled out, and it's amazing the response that we've been getting. But basically, everybody is interested in putting in EV charging, even if they're not ready yet. Because again, I think if you look at what's happening out there, especially announcements from General Motors that said in 2035, we're not going to buy any more, we're not going to support any more internal combustion engines. You can see the way the market is going. So again, I think it's a good thing. And as far as it ties back to the energy score, obviously if you had an EV charging station at your building, well, obviously that would increase your energy consumption. That would be a bad thing. But the benchmarking allows you to basically segment that EV charging out and not have that go as a penalty against your score at the building. Because why? Because you're supporting another form of carbon reduction. Therefore, you shouldn't be penalized because of that.
Great. Yeah, it seems like it's something that if you can do it, you should do it, because it's essentially being paid for.
100%. I mean, I think inevitably the buildings are going to have to provide some type of EV charger because, residents and shareholders will demand it, A, or B, it'll be a type of thing that'll be a selling component. Like if people either A, wanted to move to that building, or B, if it's a rental building, why would I want to live in this building? It doesn't have a car charging station when I can move in that building, which is just as nice in my head, and that has an EV charging, and I'm going to buy an electric vehicle in my next vehicle purchase. So it's definitely a big thing. And really what the state is trying to do is take away the angst for people going out there who are driving electric vehicles and worrying about, like, where am I going to charge? Where am I going to charge? I'm not home. So that's what they're trying to do, is just across the state, put in the infrastructure. So if I decided to ride from Westchester to the city with my car and oh God, I didn't charge today. Oh, there's a garage. Pull in, it's got an EV charging in there, and I can obviously do that and charge my car up to get home. So those are things that it's looking to do. Yeah, we can go to the next slide. Thank you. And then some of the things that are a little bit different in terms of energy reduction opportunities or carbon reduction, solar PV continues to be a potential thing to do. Obviously much difficult to do maybe in Midtown Manhattan, where you have a lot of tall buildings around you, but we certainly see opportunities for solar, rooftop solar in locations out in the outer boroughs. We also see a lot of opportunities for solar on solar covered car ports, where you basically have, if you have an outdoor location, and we're working with a few in Queens right now that have outdoor parking, that they're looking to actually do some solar covered carports where they can pull in there. And actually what we're doing is tying that into a community solar project where actually a third party developer is actually building it, and they're going to sell the credits back to the utility to fund it. But the residents get the use of the carport, and then they get, they'll actually get a lease payment from this particular opportunity to basically the fact that they're housing it there. So these are things that, that buildings can look at. It's either A, putting on solar, or B, participating in buying community solar, or C, there's a whole thing coming out called renewable energy credits as well. That'll be something else that'll allow you to kind of not have to pay the city a fine and maybe able to buy some credits instead. In lieu of paying a fine, buy some credits that would obviously help support activities like this. Some other things for on-site power is cogeneration, where you can put in a device, an electric generator that makes electricity. and then provides waste heat to heat the building as well as make domestic hot water. It does use fossil fuel. All the studies we look at, it shows that, it's pretty good and it won't have kind of an impact on carbon definitely through 2035. After 2035, it really depends on if the state does or does not actually come through and produce, all the new generation in terms of being fossil fuel free. But at least for the next 15 years, or I'll call it 14 years, I think cogeneration is definitely still a viable technology that can make the building overall more efficient, which would help the energy score and essentially make you at least carbon neutral if at worst. And then overall too, that device could also be changed to just run on some different type of programs to not impact the carbon score going forward. And then energy storage, we talk a lot about it. A little bit difficult in New York City because of the requirements from the fire department, FDNY, but definitely is a potential viable thing in outside of New York City, and where I think the market's going, because again, if we do have all this renewable energy, we're going to have to be, and maybe it's abundant during the day, we're going to have to still have it at night. So we can either do two things: store it and then discharge it, or use it for sort of like load strategies as we go forward. But certainly something that could help, at least if not manage the building's usage and have a way to store, I'll call it lower carbon form of energy and discharge over times when we need the energy to make the building much more efficient, or say much more carbon efficient going forward. So we'll just kind of wrap up here. We're getting to the end of my stuff, and we'll go through one case example. So in practice, how do we apply this stuff? Well, here's an example of building that we worked on a while ago that was looking to upgrade. They had an old, I think they used steam from boilers that was very inefficient. They had single stage or low pressure absorption chillers. They had, and again, when they were just sort of a mess on how they used energy, we actually, so the building was centrally heated, centrally cooled, not a ton of energy spaces, but definitely something that was a nice building like that to live in. The building so when we got involved, they were already working on looking at a lot of their envelope measures, mostly to local law 11, which again, I know the building owners know obviously far too well, but again, what they were doing actually had an energy benefit, because they were just doing a lot of sealing and pointing and taking some brick and actually making a difference on the infiltration of the building. So we took some credit for that on the energy side, and we definitely saw that was going to help. They converted to natural gas. They put in very high efficiency boilers. They put in high efficiency boilers as well for domestic hot water heating. They put in high efficiency motors, and they put a brand new electric chiller plant in to basically make cooling where they had the very inefficient cooling plant. So you can go to the next slide, Elise. So this was done before Local Law 97 was passed and before people really cared about energy scores as well. But we kind of did a post, look at this building. So if this building was where it was prior to us getting involved and it was under the same criteria that we have today, would have had a nice energy score of 43, which would have been a solid D, from an energy scorecard perspective. And it would have been facing like $66,000 a year of carbon penalties starting in 2024, which would have really stunk. And over $200,000 in carbon penalties in 2030 when the ratchet down on the emission level. But again, when we look at this project after, and we actually have looked at real data afterwards, this project actually scored up at a 79, was a solid B, and we actually were able to eliminate the carbon penalties over time. So putting this stuff in practice actually can reduce energy consumption, increase your score, and reduce your carbon emission penalties or potential carbon emission penalties going forward. So again, it's a lot of what we do in terms of looking at buildings. So on this building, again, it was more like going to the building, trying to assess what was there now, and then looking at what opportunities we could do to make it better for them. And again, the result, as you can see, was, emission penalties, savings, energy score. And I guess we didn't really put it here, but there was definitely an operating expense saving. We probably saved half of their cost on winter, some summer heat cooling, and probably reduced their winter consumption by 20, 25% on their energy cost as well. And we did get them back at the time $95,000 through the NYSERDA MPP program, multifamily performance program, in order to help pay for it. So definitely a win-win for everybody involved in the project.
That's great.
So so every building, we can't stress enough, every building is unique. The engineer who walks your building is going to create a unique measure of a table with unique measures for your building, as you can see on the left. And with that, it will let you know what the cost of the project is, if there's incentive, what the ROI is, as it relates to Local Law 97, what the carbon reduction would be. And it'll help you understand, after you verify the data, what plans are good for you. Do we need to create a 10-year plan? Maybe it's a 4-year plan, depending on how your building measures up against the first round of criteria for the end of 2024. And from here, boards can use this as a tool to create a plan that's best for them.
Thank you. So
Thanks, Matt.
This was obviously extremely informational and a lot for us to take in. So, we welcome you to start asking any questions that you have, and then anything that you think of later, you can always email us after, and we will of course get right back to you. So we're going to get started. For relatively new buildings, it seems that they might be impacted because they have a lot of glass surface area. They're tall and narrow towers. Is there any realistic hope for compliance? Was this already a factor when they were building?
Certainly it makes it tougher to obviously do that. I guess we'd have to assess where you really stood in terms of that. We do have a lot of buildings that they may not be at the compliance, but they're not that far off. Or there may be some things we can do, maybe on ventilation as an example, or we can certainly look at potentially buying some renewable energy credits as well going forward to avoid having to pay the city the money for a penalty. So again, I just would say that it would really depend on the building. We'd have to look at it. If it's really far off, it may be obviously very challenging to get there. If it's a little off, or we expect some penalty, it may be with some improvements, maybe some ventilation, some building management, some controls, some newer upgrade of lighting, because even buildings that were built in the last 5 years, it's amazing. We go in and still see fluorescent bulbs that we were not even LEDs. So again, it may be something that we can do. And I will say, and I'll stress that it's not like a one thing fix. A lot of times it's a lot of little measures like Matt's sheet just showed that kind of get there, or we can get you close to being there in compliance, and obviously look at some other things that are coming out to hopefully make it that you don't have to pay fines and penalties going forward.
Great. Similarly, it appears that for an amenity-rich building that's already running on natural gas for heat and domestic hot water, meeting the government consumption limits is impossible. So if it appears the government's looking to use this penalty as just another form of revenue, what is your perspective on this no-win situation? Because, can you really achieve targets in order to avoid penalties?
Yeah, again, I definitely would say it's almost the same thing. It really depends on where you are in the building to see if we can get there. Obviously, an amenity-rich building certainly is going to have a lot more challenges to do that, but maybe even a lot more opportunities as well, because again, some of the things we can look. I mean, I have some buildings that are very high in amenities, but then again, when I go into their central boiler, they still have fossil fuel air conditioning. They could switch to gas. There's definitely a lot of ventilation upgrades. There's building management stuff that we could do. And again, the whole goal, again, if not to eliminate, obviously we would love to eliminate it 100%. But again, what we're trying to do is drive down any penalties that we have to make it either A, more manageable, or B, can we then do something as part of the law as well to buy renewable energy credits and not have to pay money to the government and use that to fund other measures that we want. So it is possible. Again, a lot of it just depends on how bad the building is to start. But even amenity building, like I think the one on 76 that we showed you, was able to kind of do a good job of eliminating penalties associated with it. But again, I'm not going to take the total naysay that the city is looking for revenue, but everybody always thinks that. And I'm not saying I disagree either sometimes, but there's definitely some things that we could potentially do to eliminate it, or either shift into like a carbon purchasing and a renewable energy credit to avoid paying the city the funding.
And
Yeah.
also, I'm sorry, Matt. I was going to say, and also,
Mike, it's also worth to mention that, these local laws, they're not carved in stone. There might be changes coming in the future. And when we're talking about the future, there's also probably technologies down the road that will help these sort of buildings achieve the goals that they have to.
Yeah, I would 100% agree with that. Yes. I mean, and again, I talked about the heat pumps as well before. I think they're going to get better over time. Technology is going to get a little bit better over time. And yes, the law is still being tweaking. There's a bunch of working groups that are looking at various different things in order to help sort of, potential other ways to help comply with it as well. And I should say too, affordable buildings have a different path. We didn't really get into that, but there is if you're an affordable building, I think greater than 35% is whatever the target is now. There could be a prescriptive path that the building could actually take. And as long as we do the various measures that are prescriptively required, we can help avoid, we won't have to then pay any penalties, even if we continue to exceed the guidelines. And, some of those things include, air heating covers, controls, lighting. There's like 8 things on the checklist that we'd have to go through. And obviously working with a lot of affordable buildings as well that meet the criteria that obviously we're taking them down the prescriptive path to in order to be able to avoid any carbon penalties associated with that.
Great, that's good to know. Have you ever heard of a case where a building has 2 pipes, a 2-pipe team, it's 14 stories tall, including basement, and it was able to convert their existing steam system to hydronic?
Not so. No, not really that much on that. I think conversion from steam to hydronic at that tall of a building creates a lot of technical challenges, and I certainly would not be looking at that as my sort of go-to thing. I would definitely, on steam buildings, we like to look at ways to make the steam building be as efficient as possible, unless we wanted to go to some type of heat pump or variable refrigerant volume type system out there in order to do that. But the conversion to hydronic building for a tall building creates problems. And the simple analogy I can just say is that, the steam system's used to running like, we'll call it 2 pounds worth of pressure. And then if you try to make it a hydronic building, you probably have, now you're taking either the same pipes or you have to run new pipes and you're running like 100 pounds worth of pressure in those things. And also the steam, let's face it, steam was used for a purpose. I mean, steam has a lot of energy in a very small volume. And in order to get that same amount of energy out of water, you have to make it a lot more of it. So it generally is not a cost-effective way to do it. But there'll be other things that we could recommend to make the steam system be as efficient as possible and hopefully try to get to those points that you have.
Great, thank you. Is there an advantage in using heat pumps in heating mode instead of resistive heaters?
Yeah, 100%. I mean, a resistive heater is like the worst in terms of energy consumption, or especially cost. I mean, that's like a coefficient performance of 1, right? Whatever goes in goes out in terms of heat. So yeah, the heat pump, again, the advantage is because if it's an air source heat pump, you're trying to extract some of the heat from the air in order then to use electricity with a refrigeration type cycle to drive the energy to make a heating for it. Or if it's like a geothermal type system, we're pulling water out of the ground at 55 degrees, extracting that heat out of the water, putting some more energy into the refrigeration cycle that I described before, and making heat. But resistive heating is sort of the worst stuff, and certainly wherever we can replace resistive heating with either heat pumps or even go into a gas-fired hydronic system in a low-rise building, we've done some of those. We can certainly be better advocates of that.
All right. What about a steam absorber driven by a cogent microturbine?
So we definitely like cogen. Again, the problem with microturbines is they don't really make steam too well. They're good at heating up water. They're not good at they don't have a lot of that energy on a small scale to drive that amount of energy to make steam. So what we do find as a viable measure is to put in a cogen system and put in a hot water absorption chiller, and then recover whatever heat we can off in the summertime and use that to make cooling. I have a building now I'm working on that put in 2 microturbines a couple of years ago and really didn't have a good use of the waste heat in the summertime. And we're putting in a hot water absorption chiller to recover that excess waste heat that they were basically dumping if they kept trying to run like they were doing, and use that to make 50 tons worth of air conditioning in the building. So that's that was definitely a good way to do it.
Great. What are your thoughts on having a light bulb exchange to encourage LED usage?
So I'm all in favor of any way we can get anything more energy efficient in there. Certainly, you know, again, the thing about Local Law 97 as it turns into carbon emission penalties is that they look at the entire use of energy in the building. So anything you can do or encourage shareholders to reduce energy consumption in their own apartment space is only going to have a positive impact on reducing the carbon penalty associated with the building. So I'm not saying you have to buy everybody bulbs for everything, all cases, but certainly, you know, encouraging, you know, some bulbs is good. And I will say there's also some nice candidates and programs that under the MFEEP program that actually could pay for some of the bulbs, like simple screw-ins and stuff like that, actually to make it free for those type of things. And those are certainly things that Matt could help you with.
Yeah, and Mike, that's exactly what I was going to say. There are Con Ed programs available to unit owners themselves, including LED bulbs and some of the low water faucets mentioned earlier.
Great. All right. So is it true that the charging ports for EV chargers are not comparable between manufacturers right now?
Yeah, so a lot of the manufacturers have their own proprietary type systems. So certainly Tesla has their own proprietary system, but although I should say that it will also accept, you know, a port from a generic, you know, system that's out there. So if you look at the funding that the state is putting in, where I talked about before, under this Make Ready program, where they'll pay up to 100%, the 100% is generally for generic chargers that have the ability to charge, you know, multiple type of vehicles and sort of have the uniformity amongst it. If you try to put a proprietary system in there, they actually will pay for it, believe it or not. They'll actually pay up to 50%. So, you know, I have a project that I'm looking at a hotel in Midtown that happens to be owned by Jaguar, and they want to put a couple of charging stations proprietary to Jaguars. And, you know, those could potentially be 50% funded as well. So, yeah, they are all different in some respects, but, you know, we've been putting in non-proprietary sort of uniform stuff on the EV side. And I think that's where really the market's going to go, where you can come into almost any charging station and charge up your car to do that. And then the sockets will accept, you know, the socket will accept the different ones.
Great. Do you have any concerns with natural gas conversion with gas exploration being carbon intensive?
The answer is long-term, yes. Short-term, no. And I say short-term, the next, you know, certainly my working lifetime here and beyond is in my head still short-term. Again, I think we have to get to certain form of lower carbon fuel. I think, you know, the utilities and the country certainly have put a lot of money in infrastructure to extract and utilize natural gas, which obviously is an abundant resource in the United States. But obviously on the flip side, we are looking at a lot of different things to try to make, you know, non-carbon or renewable energy. But I still think that certainly, you know, gas is going to play a role. Natural gas is going to play a role in the future on either peak shaving stuff or on the heating side, because it's going to be very hard to and any type of effectiveness convert these buildings and dense buildings over to another form of fuel or type of fuel. Because again, let's face it, steam, gas, even oil has a lot of energy in a small volume, and it's easy to transport it. So again, I still think that if you're facing a carbon penalty in 2024 or 2030 and gas conversion is an option for you, you know, I would definitely say go forward with it, because you'll pay for that, you know, over time. You'll pay for it before you have to make the next thing. And then if some other technology comes along in the future, then we can kind of look at that. But I wouldn't stand clear of doing a conversion for some of the exploration stuff as well.
All right, good advice. And we're going to be wrapping it up here. So I'm going to finish with this last question. And then of course, if anything, you know, comes to mind, we encourage everyone to email us. We'll have all of our information while we complete. So will Con Ed steam reduce its carbon footprint perhaps by creating steam with green electricity, or should we abandon it?
That's a good question. Certainly, you know, Con Ed steam is sort of a waning enterprise, right? I worked for another company for a while called Trigen, and we ran steam system outside of New York. But, you know, people leave the steam system all the time. You know, it's like, you know, so many percent per year, which means a lot of that fixed costs going to get passed to other people over time, and obviously the carbon emission component of the steam system is obviously reality. I think Con Ed will not abandon it. And I think, I think what they'll try to do over time is figure out ways that they can make it more green and efficient. I think, geothermal is a potential component that may actually help them, where they may be able to kind of, grab some energy from the ground, or where they can kind of, not have to start with zero and sort of heat up the steam that way. There could be some other ways they can do the technology. I mean, the good thing about the steam system is too, on the cogeneration side, where they make electricity, they're able to kind of make that efficiently and dump that to the system. But, I think certainly, the Con Ed steam system maybe at some point will go away, but that will definitely be way in the future. And I just think that it'll have to be sort of when, something else comes around, where we can take these very, big dense buildings that have a very long legacy, especially commercial buildings, and sort of substitute the heating with some other type of technology. And I think once we figured out that part, where we can basically heat a building in a very small footprint on a very big building, then that'll cause the death of the steam system. But I think it's way ahead from now.
Got it. Well, that is good to know. You have been a wealth of knowledge. Thank you so much, Michael, Matt. This has been very informative, and I personally learned a lot tonight. So I thank you so much for all your time and energy. If anyone has any questions, we have all of our information here. We encourage you to email us and ask anything that you're still thinking about. We have all of these wonderful resources available to you. So have a wonderful evening, a wonderful Earth Day. Stay healthy, and we hope to see you all soon. Have a great night. Thank you.
Thank you, everybody.
Bye.
Take care.
Thank
Thanks.
you.
Bye-bye.
Thank
Thank
you.
you. Bye.